먼저 초청 강연입니다. 싱가포르의 빔 기반 건설산업 디지털 사례에 대해 싱가포르 국립대학교의 저스틴 여 교수님께서 발표해 주시겠습니다. 큰 박수로 맞이해 주시기 바랍니다.
Thank you so much for inviting me. I would like to express my thanks to Mr. Yeoh, Director of Ministry of Land, Infrastructure and Transport. Forgive me if I do not pronounce the names correctly. I would also like to thank Mr. Kim Hyun-jun, Vice President of Research, Korea Institute of Civil Engineering and Building Technology, and of course I would like to express my thanks to my host, Professor Ji Kwang-suk from Korea University. Topic of my talk today is on the digitalization of Singapore's regulatory submissions. So I'm going to be sharing a little bit of what we have developed in Singapore with regards to regulatory submissions of BIM as well as other construction documents. Okay, just a quick introduction of myself. My name is Justin Yeoh. So I'm a senior lecturer from the Department of Civil and Environmental Engineering in National University of Singapore. I've completed my PhD in NUS, and I was very fortunate to do a postdoctoral degree in the United States, Carnegie Mellon University. My primary research interest is on BIM, as well as construction automation, robotics, and digitalization. Now, in NUS, my research lab, we call ourselves the Built Environment Automation and Digitalization Lab. We look at research of the built environment on an end-to-end life cycle of the building. So we cover things from intelligent design, digital construction planning, lean virtual design and construction, construction automation and robotics, and even up to data-driven building asset management. So for today's talk, I'm going to be giving a broad overview of Singapore's CoreNet X system. So this is a new system, well, it's an old system, but we are currently developing a new version of this CoreNet X system that we will be launching very soon. I will also be talking a little bit about our BIM policy in Singapore and how we have gone about embracing something that we call the IFC SG standard. And I will also share a little bit about my research project with the Singapore government that is looking at an automated model checker for structural submissions. Like I mentioned earlier, CoreNet has a long history in Singapore. It started in 2001 with the launch. And over the last 20 years, we have gone through many changes in CoreNet. And I'm happy to announce that, I'm happy to share that CoreNet X will be coming into force in Singapore soon. So this is a new version of something that we have been looking at in terms of submissions of digital regulations in Singapore. So let me share why we are doing this. In Singapore, when we go through the submissions process of our regulations, what happens is a consultant or a contractor would need to liaise with many different government agencies to get these necessary approvals before he can start building his project. This process is very long drawn, and he will have to coordinate independently with each of the government agencies. And what potentially may happen is that one agency may have a conflict with another agency in terms of the regulations that's in place, and so this will lead to a lot of rework in terms of submissions of the submissions of the regulatory documents to the government. So this is a very inefficient process, and one of the things that we want to do with this process is to see if we can use digitalization to help this process and improve the process. So this is the revamped process that we are hoping to achieve with the CornetX system. So the CornetX system has re-envisioned the entire submission process. In this CornetX system, we are looking at a coordinated means of delivering our information. And after we have delivered this information, we have designed something that we call the three-portal process or the three-gateway process, where we have consolidated and streamlined the entire submissions process through these three gateways. So I'll share a little bit more about what these three gateways are. And finally, one of the big hopes that we have with CornetX is that this would translate into productivity savings in the construction phase itself. So it's not just in the design phase. We are hoping that this will actually lead on to savings and productivity gains in construction. So CornetX, so we have a very big vision in Singapore about what this CornetX is supposed to be. We are looking at this as an ecosystem of regulatory approval for building works, right? And the hope is that this will accelerate the transformation, the digital growth of our construction industry. So the image that you see here paints the overall architecture of the CornetX system and all its various components. So if I could summarize this, I would say that there are 5 main components that makes up this architecture of CornetX. So on one hand, we have the pre-submission checks. So what this allows is for the consultant, the engineer, to check his designs before he submits this to make sure that his designs are verified and the data is good to go. Second, we have something that we call the CornetX portal. So this is a secure submission portal that is managed by the government and developed by the government. So this acts as a data security layer to protect against unwanted intrusions in the system. Third, we have the automated model checker. So this automated model checker would run through and it will automatically detect if there are discrepancies in the models, and it would then report to the user if there are such discrepancies. Once we have cleared this automated model checker, the different government agencies would now be able to collaborate through one single platform on this particular project. So this becomes a one-stop regulatory response from all the agencies. So instead of the current system where we have responses between the contractor and different agencies one at a time, we are consolidating all these responses together. And finally, once the responses have been issued and the data has been verified, we are also introducing a centralized data hub to keep all these models, all these submissions for future references and archiving. So the regulatory process that we are looking at, so I introduced the 3-gateway system. Well, it's a 3.5 gateway now. So on one gateway, we have the design gateway. So this is actually looking at all the necessary information for the design stage to come in. So the engineers would have to prepare his information, prepare his submissions as well as the models for submission at the design gateway. So after the design gateway, we have an optional gateway that we call the piling gateway. The reason we have pulled the piling gateway separately is because the piling gateways or the piling process in construction is one of the bottlenecks in Singapore. So we want to expedite the piling. So if we can expedite the piling, we can actually start work on the building earlier. So after the piling gateway has been cleared by the engineer, then this goes down to the construction gateway, where the construction gateway we will be looking at more detailed design requirements, and this is actually the must-haves in the superstructure as well as the construction and the launch of sales. And this will actually coincide with the actual construction of the building or the facility. And finally, we have the completion gateway, which would look at the compliance to the approved design, the statutory completion, as well as the collation of the as-builts of our models, as well as our submissions. So to summarize the key ideas of what we're trying to achieve with this 3-gateway system, I would say we are looking at a one coordinated response. This makes it streamlined for the contractor and for the engineer. He only needs to take care, right, of one specific response from the government. We are looking at a maximum of 2 iterations at each gateway. This is a goal that we have set with the implementation of this particular process to improve our productivity. And 3, we are looking at the 3-gateway system, right, as a streamlining process to improve ourselves. And we are also going to hold ourselves, or at least the government is going to be holding itself to responding to the submissions within 20 working days. So this is a big improvement in our current system. So the current system, if we are unlucky and we go through several iterations, it could take months of work. Today, with the introduction of Cornet X, we are hoping to cut this down to 20 days. I want to stress on one thing, and that is that this gateway, the change in the gateway, the change in the process, does not minimize the liabilities, does not minimize the responsibilities of the engineers as well as the contractors. So they are still expected to ensure that the designs that they have provided fulfills the regulatory requirements at any time. So this is just a stop check of what we have done with the Cornet X. So we have already completed the first phase of the collaboration platform, and in this collaboration platform, some of the key features of this platform include the extraction of different views. So this is to facilitate different regulatory agencies with different requirements. They can now focus on what is important to them. We also have the coordinated review and virtual collaboration. So now we can have all the different agencies looking at the same information, and if there are conflicts between the agencies, this can be quickly cleared, right? As opposed to the current system where we have to wait for weeks before we clear these conflicts. And last, of course, is that we are able to issue a coordinated response to the industry, and this cuts down the uncertainty and ambiguity in the response to our contractors and consultants. So there are a lot of changes that's coming in Cornet X. One is that we will be streamlining our process. So previously, what used to take 20 submissions now is going to be a lot more streamlined. We are expecting a 20% reduction in the time for obtaining the approvals. Previously, we would allow 3D files to be submitted in the native format. We will continue to allow submissions in the native format, but we are going to be moving towards something that we call the IFC SG, which I will talk a bit later. And the submissions are now cleared independently, so there is no central oversight of each submission. So this is one of the big changes that's coming. Because of the gateway system that we have implemented, we will issue a coordinated clearance of all the different submissions. And the agency's response previously used to be quite lengthy, right? A couple of months before they get back to the contractor and consultant. Now it's going to take 20 days. Okay, so that gives you a broad overview of the Cornet X system and what we are hoping to achieve with Cornet X. One of the key enablers in technology that we are trying to implement in Cornet X, right, to make Cornet X work, is the IFC SG. Okay, so just to give an idea of what this IFC SG is like, the issue that we have today is that the information that we have in the construction industry is very varied, and it may come from different softwares, and the different softwares may not talk to each other. So to address this issue, Building Smart, which is a global community, has developed something that we call as the IFC, and Singapore has been actively adopting, right, the IFC standard because it is open, it is neutral, it is platform independent, and allows us to customize what we need from this particular platform or from this particular data structure. So, the issue with IFC and why we have decided to embark on the IFC SG is because the IFC is not complete. It's not enough information in the IFC currently for us to be able to do the kinds of regulatory checks that we want. So, what we have done is that we have taken on board the IFC, and in fact we have looked specifically at something that we call as the IFC 4 reference view MVD. So this is a specific subset of the IFC standard, and we have localized this by making use of something that we call as the user-defined attributes, right, within the IFC. It's a mechanism that allows us to localize the IFC. So using this, we are able to create new entities, we are able to create new attributes and properties that we can put in into the IFC standard. So this allows us to do a more comprehensive checking of building submissions. I do have to share a little bit. The IFC files potentially can be quite big. So we have put in place certain guidelines to the industry to follow. So one is that the files that submitted has to be less than 800 megabytes. For large complex projects, we advise them to break up the files into smaller pieces. And one of the things that we are trying to get the industry to do today is to georeference all these files together. So all the IFC files, we are hoping to georeference this. Why? Because some of the regulatory submissions requires a larger scale than that of the building. So we want to georeference this to something that we call the SVY21 coordinate system. Now, to help the industry in adopting IFC SG, BCA, which is our Building Construction Authority, the government agency in charge of buildings and construction in Singapore, has implemented something that we call the IFC SG validator. So this validator will help users to check whether, right, the models that they have, whether these comply to the IFC SG schema. So at this point in time, this IFC SG validator is available online, so anybody can use this IFC SG validator, and it's there to address common data errors, so things like misspelled properties, missing elements, as well as wrong property sets being used for the elements. So this is an early check, right, of the IFC SG to make sure that the industry is using the right and providing the right sets of information to the regulators. So, the IFC SG is a big change in Singapore. When we first launched the IFC SG, there was some resistance from the industry because this represents a fundamental shift in the thinking and in the work processes of the engineers and the consultants. So some of the challenges that we have been looking at, and some of the mitigation and that we have been thinking about with the government agencies. So for one, there is a steep learning curve for the IFC SG. So a lot of the engineers and the consultants 2 years ago, 3 years ago, were not familiar with IFC, were not familiar with IFC SG. So what we have done is that we have worked together, right? The universities in Singapore, the polytechnics in Singapore, we have worked together with the government agencies to educate through onboarding clinics, through sessions, sharing what IFC SG is and what are the benefits that can be derived from IFC SG. We do admit or we do understand that there is a longer modeling process that is involved in preparing the models for IFC SG. But the promise is that yes, while they may spend more time doing the modeling, we are hoping that this would lead to shorter waiting times for the regulatory submissions. So that would create a win-win situation for all parties that's involved. whether it's the government agencies or the consultants and contractors. And there's also a requirement now for interdisciplinary model coordination. So the consultants and the contractors are now being forced to work earlier on in the design process. And the last one I think is perhaps the most important is that we now need to have a very consistent modeling standards and guidelines for the industry. And this is something that the authorities have been working on, and they have been sharing all these standards on the CornetX website. So the last item that I'll be talking about will be our automated model checker, which is working on the structural submissions. So just wanted to give a shout out to my research team, Mr. Chua Kiong Kiat, Ms. Jarun Singh, and Mr. Wilfred Lin. So these are my engineers who have been working with me on this project for the last 2 years. We have been working very closely with the government agencies. So the government agencies who has been facilitating our projects, Engineer Chang Bek Mei, Engineer Brian Phua, Engineer Lee Xuan Yan, and Ms. Lee Yan Ling. So they have been helping us in developing the system for the structural engineering. So just a quick understanding of what are the industry challenges when we talk about structural submissions. So structural submissions represents a slightly different paradigm from the architectural submissions. There are a couple of people who are involved in the structural submission, and these are the BCA processing officers from the government agency, as well as the engineering professionals who does the design. Now there are a couple of challenges that we are facing in the industry. One, inconsistencies between the BIM and the analysis and design models. So the analysis and design models are the information, the designs that we are getting from the engineering softwares that we're using. We find that it's very difficult to identify the structural elements in BIM from the engineer's reports, and it takes a very long time for the processing officers to review and check the engineer's output. So we want to address these three issues. And before we launch into those three issues, I thought it'd be good to share a little bit about how the structural engineer works and what's his workflow. So the first workflow, what I call as the ideal workflow, is where the structural engineer receives the architectural BIM. So he receives the architectural information. From there, he creates what we call as a structural BIM, which represents the structural elements that he needs for his submissions. And from this structural BIM, he will then put it into his analysis and design engineering software. And from this, he will then run the analysis and design softwares to get the computations, to get the sizes of his columns and beams, and so on and so forth. Now, once he has done all these computation, he would then do something as what we call round tripping. So we would round trip the information. So from the analysis and design, we would put the information back into the structural BIM. So we update the structural BIM with the design information. And from there, we would then coordinate the structural BIM together with the architectural BIM to make sure that that process is correct. However, for various reasons, normally due to time, the engineers would do a shortcut process. So instead of going through from architectural BIM to structural BIM, they directly go from architectural BIM to the analysis and design and build the analysis and design from there. So one of the things that we are trying to do with our project is not to change the engineer's workflow. We recognize that there are two ways of doing it, and we are not saying that one is better than the other. We will support both ways of doing work. Okay, so we managed to get a few participating software companies to join us. So we have Autodesk Revit, Tekla Structures, ETAP, SAP 2000 SAFE, which is from CSI, Tekla Structural Designer, Tekla TEDS, and as well as STAT Pro. Being in Korea, I know Midas is a very big company here. So we actually did ask Midas, but this was 2 years ago. Midas were not ready with their APIs at that time, so we unfortunately were not able to collaborate with Midas. However, I hear that there are some developments, and we will look forward to seeing what those are from Midas. Okay, so once we had on board all these different software applications, what this does in terms of the structural proposal is that we now have a method in which we can take the information from the A&D, the analysis and design softwares, and export those information into something that we call the XMI. So this is a secondary format that we have created that we can export from all the analysis and design softwares. Now, why are we doing this XMI is because we want to be able to extract out specific structural information that normally would not be extracted out from these software. Then, on the other hand, to facilitate the regulatory compliance, once the engineers have submitted the structural beam onto the Cornet X system, in the form of an IFC SG file, we would do a conversion and we would then do a comparison between the analysis and design as well as the structural beam information. So by checking these two information, we can now do things that previously could not have been done, such as checking for engineering rules, which I will talk a bit about later. Okay, so back to the three challenges that we had. So to address the three challenges, so one was on inconsistent data. We have implemented something that we call as the XMI schema, which would help us to address the inconsistencies. The other is that the difficulty of trying to identify the elements from the engineers' reports and models. We have created a matching algorithm that would help us to check, right, to make sure that one element or one column in the structural beam is actually a column in the A&D software. And the last is, of course, we have implemented certain engineering rules and checks to help the government agencies to check the designs of the engineers. So this our first feature is the cross-information model, the XMI schema. So this is something that we have developed as part of our research. We have mounted the information on a website called xmi-schema.com. This is a growing schema that's under development, so there's changes that's still ongoing, but the core principles are still there. We intend to make this an open schema for structural elements, and this would represent the common data between the analysis and design as well as BIM. The second is the matching elements. So we have looked at various different algorithms to help us to identify when, in one model, whether this is a beam and it's the same beam in another model. We are now able to do this with good accuracies. And so we have implemented a series of systems that will allow us to make this automatic. And we also introduced something that we call the engineering rules and checks. And we have implemented 30 checks and 60 rules. So basically the 30 checks are there to ensure that the models that have been submitted, these are good to go, which means that we can use the models for our purposes. And then we have implemented 60 rules. Now these 60 rules are engineering rules, wherein the engineers would apply their rules of thumb, which means that it's a rule that is based on their experience, and they would then be able to assess whether this is a good design or it's not a good design. And from there, the outcome of using this system, we would allow the system to tell the engineer if it's a pass or it's a fail, or we also have a third state that we call the warning state, which means that the model is actually okay, but they need to provide more information, supplementary information, to the government agencies. Okay, so this is an example of the engineering check, right? So for this particular check, we are looking if the total area of the longitudinal reinforcements required is less than what is provided. So we do a check between the analysis and design model as well as the BIM. Another rule that we have implemented in our system is the span depth ratio of the reinforced concrete beams. and whether this is within the expected ranges or norms. So these expected ranges or norms, these are based on the experience of the engineers that we have talked to, and they have given us a range of numbers that we have put into the system to do these back of the envelope calculations. Okay, so I actually have a short video showing the development of our system. So the first one is, this first video is on the export plugins, which means that how are we able to export the plugins. Yeah, very nice music. Yes. So we have plugins for all the 8 different softwares that we introduced earlier. One of the things that we're doing with the plugins is to transfer the information from the analysis and design and transfer it into the structural DIM. And what the users need to do is basically to install the plugins and press a button and export the information. So the information is, the XMI schema would generate a JSON file, like what you see over here, and all the information that's required is kept inside this JSON file. Okay, now, so once the XMI files and the IFC files have been generated, we are now able to put it into our system. So this is an early version of the system. We are able to create projects, put in new projects, right? And we are now able to do a comparison between the analysis and design as well as the IFC SG files. So finally, this creates a dashboard view telling us which are the checks that have been passed, which have failed, and we can even zoom in to see which are the elements where there is a discrepancy. So this shows the different status of the rules and the checks. So it's color coded so that you can see the different status. And the last thing that we provide is to be able to download the analysis results as a supplementary file that you can then submit this to the authorities if they request for it. Yep. So looking ahead, I think that we have learned a lot in this particular exercise of Cornet X. We have also learned some practical issues that I thought it would be nice to share with everybody here. One is that there is a lot of maintenance of this software. There's a lot of maintenance of this system that needs to happen. One, because a lot of the information that we are dealing with requires native BIM. We need to have a means of renewing the plugins every year, because every year there will be a new version of the native BIM software. So again, one other issue is that not all software is supported. Like I mentioned earlier, we talked to Midas previously, and because of the lack of an API at that point in time, we were not able to bring Midas on board, even though Midas has a sizable market share in Singapore. Another issue that we also face is that we need to be more stringent in how we enforce our modeling practices for both the A&D and BIM software. And the last is that we need to have, we have started to look at the scalability and the security of data now that this becomes a national platform. So a roadmap for Cornet X, again, I'm happy to say that in 3 days' time, there will be a soft launch of Cornet X in Singapore. So we're going to be phasing the introduction of Cornet X in Singapore. And the first phase will primarily focus on the architectural codes. The structural codes will come in on the 1st of June 2024, and we are looking at mandatory submissions for all engineers and builders in April 2025, and this will be applicable for all projects with GFA more than 5,000 square meters. Yep, and with that, I end my presentation. Thank you.